Hey guys, and welcome back. And today we're going to be talking about the volume of a sphere, our last lesson in volume. So our learning target again is to determine the volume of 3D objects involving circular edges. So as you guys have seen, every one of our 3D shapes have some circle involved, which makes these formulas slightly different than triangular or rectangular prisms. Specifically, we're seeing a lot to do with pi. Our success criteria is going to be to derive the formula for the volume of the sphere. So we're going to figure out where that formula came from, and then we're going to use it to calculate the volume of a sphere, and we're also going to use it inside out, just like our last 3 lessons. So let's take a look at our key idea. It says the volume of a sphere is the number of unit cubes, or cubic units, needed to fill the sphere. You can find the formula for the volume of a sphere by comparing it with the volume of a cylinder. Okay, this is important because that's the same way that we derived the formula of a cone. So I want you guys to really think about a cylinder whenever you may forget what the volume formula for each of these shapes is. So to illustrate this idea, I have a cylinder and a sphere. Let's say I fill the cylinder 1/3 of the way with water. Okay, so that's what this blue area is for. I filled it with water. And then let's say I filled the sphere with water. Okay, that's why the sphere is blue. What happens is if you place the sphere, okay, let me give you a little illustration. If you take this water and put it inside of the cylinder, you can see that the water fills up the cylinder all the way to the top without spilling over. So what that means is 1/3 of a cylinder's volume plus, okay, so 1/3 of a cylinder plus a sphere is going to equal 1 full cylinder. And the reason why I write that is that's how we come up with the formula. So the formula for a cylinder, that's this one right here. Let's mark that. Is pi r squared h. So now, with a sphere, there really is no height. If you think about a sphere, it only has radii going everywhere. Back, forward, front. It's just a radius that is creating this sphere. A radius turning in all 3 dimensions. There's no height. It's just the radius spinning around. Unlike a cylinder, where the cylinder just has a radius. I'll illustrate. Let's see. Let's do purple. Okay, a radius right here. Okay, and it can go around the base. The radius can go. Okay, but there is no radius this way. That's the height. A sphere only has radii. So what we're going to do is we're going to change that h into 2 radii. Okay, because if you think about it, if we go from the center of the sphere, there's a radius going from here to here. There's also another radius going from here to here, to the bottom of the cylinder. Put that together, you have 2 radii. So instead of talking in terms of a height, we're going to talk about in terms of radii. So if we plug in, if we replace h with 2r, we can simplify this to be, well, let me show you the breakdown here. If I were to separate this 2r, let's say I were to move the 2 out in front of the pi. Okay, so I've got 2 pi r squared times r. Well, this lone r really does have a power of 1 on it. And if you remember our exponential properties, if you're multiplying 2 variables together that are the same base but different exponents, we just add the exponents. So the formula becomes 2 pi r cubed. And since the sphere is filled 2/3 of the space of the cylinder, we take 2/3 of that formula. So we just need to simplify this a little further, which since all of these numbers are being multiplied, we can simplify this just by putting together these 2 numbers right here. You don't have to combine it with the pi. Which then gives us the formula, which I'm going to circle here. Volume is equal to 2/3 times 2 is 4/3. So 4/3 pi r cubed. That's our ultimate formula that we're going to use with the sphere. Okay, now I do want you to memorize these. We are going to make flashcards and memorize all the formulas, but if you ever forget one, you can think logically about how one was created, how the volume of a sphere was created from a cylinder. So let's take a look at our first example. It says to the nearest cubic foot. Now remember, that's to the whole number. Okay, if they don't say tenth or hundredth, they just say to the foot, to the inch, to the centimeter. They want you to round to the whole number. How much space is contained inside the water walking ball? Use 3.14 for pi. So when you're talking about space being contained, they're really just saying, what's the volume? Okay, so try to practice good memorization skills, and on every problem you do, rewrite the formula to try to commit it to memory. So on the last slide, we had volume equals 4/3 pi r cubed. Now in this picture, I see that r is 3 feet. Remember, r goes from the center of the sphere to the edge of the sphere. So all I'm doing is I'm taking that 3 feet and I'm plugging it in for r in the formula. Volume is equal to 4/3 pi times 3 cubed. Now I start to simplify. It does say use 3.14 for pi, so I could plug a lot of this in my calculator. Let me show you how I would plug it into my calculator. I would probably first type 3 cubed. So if you type 3 cubed in your calculator, that's going to change it to 27. Then I would probably take that 27 and multiply it by 4/3, either using the fraction button, or if you're not sure how to use a fraction button, or if you don't like your answers to be in a form of a fraction, here's a little side note how to calculate this. Okay, so 27 times 4/3 is the same thing as punching in your calculator 27 times 4 divided by 3, which when you do that is going to equal 36. So these two numbers simplified together is 36. Now, if these instructions said leave in terms of pi, this would be my answer, 36 pi feet cubed. But it doesn't, it says use 3.14, so I'm going to go ahead and punch in 36 times 3.14, and that gets me rounded to the nearest whole number. I'm getting 113.04, which rounded would be 113 feet cubed. Go ahead and give this a try in your U-Try. All right, in the second example, we have a spinning quarter. When it spins, the quarter forms what happens to be, or what appears to be, a sphere. To the nearest hundredth of a cubic inch, how much space does the spinning quarter occupy? Use 3.14 for pi. So again, it's talking about space being occupied. So that's just saying, what's the volume? Okay, what's the volume of this spinning quarter? If I had to fill the space that this spinning quarter is occupying with air, with water, whatever, I want to know how many cubic inches there are. Now, I'm seeing a dimension here, but the dimension is going from one end of the quarter to the other, as indicated by these arrows. That means it's creating a diameter. The relationship between a diameter and a radius is diameter equals 2 radii. Or we can also write this that diameter divided by 2 is equal to radius. So I'm going to take that 0.995 and I'm going to divide it by 2. So 0.995 divided by 2, and that's going to be our radius, which is 0.4975. Okay, so we're going to need to be careful. Don't round before you get to the end of the answer, or else it may skew things a little bit. But if you have to, you can. Just try your best not to round anything till the end answer. So now I'm just going to repeat the same process. Volume is equal to 4/3 pi times r, which is 0.4975 cubed. Okay, so like I said yesterday, you should always try to punch in your calculator the exponent numbers first. So 0.4975 cubed. I'm getting a very large number in my calculator. So I'm hoping we're listening to this because I'm going to keep that in my calculator. I'm just going to punch it all in at once. So I pushed this in my calculator first. Then I'm going to multiply by 4 and divide by 3. And then I'm going to multiply by pi. Okay, I think that's probably the easiest way for you not to make errors. So with the number that's in your calculator right now, it should be 0.123134359,375 and on. I'm going to punch in times 4 divided by 3. Okay, I'm getting another big long number, 0.164179145833333 forever. I'm going to hit times 3.14. So now I'm going to write down quite a few numbers and then round to what they're asking me to round to. So, get it darker. Okay, so I've got 0.515522517. That should be enough numbers because the rounding directions say to the nearest hundredth. Well, the hundredth is right here. Okay, that 1. So I have to look directly to the right, which is a 5. If it's a 5 or above, that means it rounds the hundredth up 1. So the volume of this quarter, the space that it takes up, is equal to 0.52 inches cubed. Let's have you guys give this a try in your U-Try. All right, so I've got another example that mirrors what we did the day yesterday and the day before, where we have to work the volume formula inside out. So they say an agate geode is spherical and has a volume of about 904 centimeters cubed. Geodes are often found in gem shops, sliced in half like the one shown. What is the radius of the geode to the nearest centimeter? So I'm again going to use my formula. I'm going to write that first. Volume is equal to 4/3 pi r cubed. I'm going to take that 904 and I'm going to plug it in for volume. So 904 is equal to 4/3 pi r cubed. So order of operations, we need to remember, please excuse my dear Aunt Sally. We're trying to solve for r. We're trying to get r all by itself. So we need to go backwards. So in order to do that, I think it's easiest first to combine the 4/3 and the pi together. That way we can just divide that number off and then cube root each side. So in my calculator, I'm going to punch 3.14 for pi times 4 divided by 3. So now I have 904 is equal to 4.18, and I'm going to round this because it says 66 all the way to a rounded 7, so 1.487 r cubed. So now we just need to get rid of that 4.187 by dividing it off. And I get r cubed is equal to, so in my calculator, 904 divided by 4.187. That gives me 215. It does say to the nearest centimeters, the whole number, so I'm going to go out a couple numbers here. I'm going to put 0.906. And then I need to cube root, not square root, but cube root, because it needs to cancel with the cube, both sides. So I'm going to keep that number in my calculator, and I'm just going to hit the cube root button. If you can't find it, please ask for help. So radius is equal to 5.999, and there are more numbers after that, but it says to the nearest centimeter, so that means to the nearest whole number. Okay, so all I really need is that 10th, that 9 right there, that will round that 5 up to a 6. So my radius is equal to 6 centimeters. Okay, and I'll write it over here as well, just in case you can't see that. Okay, let's have you give this a try in your U-Try. There's no picture here, but if you need to draw a picture, go ahead. But you're still doing the same thing. They give you a volume. You need to plug that in for V in the formula, combine the 4/3 and the pi together, divide it off, and then cube root. So for our last example, just like in all the other days we've been studying volume, we have a composite figure. So two figures put together. It says find the volume of the figure, use 3.14 for pi. Now if you notice, first we should probably pick out what the two shapes are. This isn't just a sphere. This is a semisphere. Okay, a semisphere is just half of a sphere. So what that means is we're going to have to take half of what we find as the volume of the sphere. So the two shapes, we got the semisphere, and I also see a cone. The volume formula for a full sphere, as we've been practicing, is 4/3 pi r cubed. So I'm going to plug into that formula first, which I see a diameter of 6, which means the radius is equal to 3. So I need to plug in 3 for my radius. Volume is equal to 4/3 pi times 3 cubed. I'm going to leave this in terms of pi so that I don't have to round. 3 cubed is 27. And then on my calculator, I'm going to punch 27 times 4 divided by 3, which is 36. So the volume of a full sphere, if these were the dimensions, would be 36 pi. But this is a semisphere. So we need to divide that in half for the semi part. So really the volume is 36 divided by 2 would be 18. So the volume of the semisphere on top, which is this guy, that's going to be the 18 pi. Now we need to find the cone that's below it. So for the cone's formula, we learned this yesterday, volume is equal to 1/3 pi r squared times h. Well, again, we already found our r. The radius is 3. But then the height they've indicated as 7. So I need to plug that in. Volume is equal to 1/3 pi times 3 squared times 7. So I'm first going to simplify these guys and leave it in terms of pi. So volume is equal to 3 squared is 9. So I'm doing 9 times 7 and then dividing it by 3 or timesing by 1/3. So really I have 21 pi here. So now I just need to combine the 18 pi and the 21 pi. You can treat pi just like it is a variable. So I can just add 18 and 21, which gives me 39 pi. Now they do say use 3.14 for pi. So now all I'm doing in my calculator is punching in 39 times 3.14, which gives me 122.46. Since it doesn't have any rounding instructions, that's what I'm going to leave my volume at for the cone, or for this particular shape. So I'm just going to add my units now. This was centimeters cubed. So I had to decided to add these two because it was like you had two shapes being put together. If you see that one shape is being punched out, deleted, cut off, that would be subtraction. So let's have you give this a try in your U-Try.